This is a presentation of Michigan State University's Knight Center for Environmental Journalism.
Welcome to Environment. Hi, I'm Jamal Spencer. Global warming, greenhouse effect, climate change. The words may change, but the forecast remains the same. Scientists and researchers can't change the past, but finding a solution now can change our future. Please join us as we take a look at some people who are trying to reverse the cycle in Meltdown.
You know, in some respects, I think we've caused global warming, and it's happening, and we really can't stop it.
The experts say that we need to start doing something now about carbon dioxide if we're going to stabilize the atmosphere and prevent truly profound effects on our climate. So the big problem for the coal industry is, well, what do we do the next 20 or 30 years? You know, they've got power plants proposed all over the country, and there have been several examples recently where regulators have said, no, we're not going to approve that plant because we're concerned about the carbon dioxide emissions from it. And I think we're going to be seeing that more and more as society, as regular citizens, and as investors start to point out the climate crisis and demand that something be done about it.
We see glaciers, particularly in Alaska, are really disappearing right in front of our eyes. We see changes in runoff. All of these things seem to fit a pattern, and we see the biological changes too in the Arctic that we're trying to get a handle on.
But we're transiting into a warm world whether we like it or not. And in some respects, I think that we better start preparing to live in a warmer world.
It's a harmony of ice, snow, water, and light. The sparkling blue Arctic Sea shimmers beneath the unsetting summer sun. Its desolate beauty is hard to imagine, and for those who have been here, impossible to forget. And yet, through all this shimmering brilliance, for many, it's beyond belief that these surroundings are in harm's way. A discord between nature and humankind's voracious needs for energy and power, the climate changes taking place in the Arctic provide a look into the planet's imminent future. The Arctic is the planet's early warning system. According to published reports, Arctic average temperature has risen at almost twice the rate as the rest of the world in the past few decades. These changes mark the first time in a long time that influences on the environment seem to be having such far-reaching global effects. Measurable effects on ocean temperatures, migratory patterns, and glacial melting have put the scientific community on the alert, prompting two scientists from the University of Tennessee to launch an international research expedition. This is the U.S. Coast Guard icebreaker Healy. Built not only to serve the tough requirements of the Coast Guard, she is also equipped with electronic sensor systems, mechanical equipment, and living space to accommodate the needs of Arctic researchers. On its 2004 expedition, the ship was both home and job site to an international team of scientists, students, and teachers. The University of Tennessee's Dr. Lee Cooper, the project's co-director, explains.
A lot of people wrote proposals. Some of us are out here and from a number of different organizations, or number of different universities, both in the United States as well as some other countries. And we're trying to, I think, doing a good job of putting a fairly unprecedented degree of attention on a whole bunch of different aspects of environmental change in the Arctic, and that's what we're doing. Dr.
Cooper's wife, Dr. Jackie Grebmeyer, makes up the other half of this team. She heads up the expedition, and together they have made Arctic research their life's work.
In my lifetime, I've seen, for this ice retreat, I've seen changes in my animals that I study. And so we'd go back onto time series of those animals that the Russians have collected. So 100-year time series, 70-year time series. So it impacts local communities, the changes that we're seeing.
The Healy, the largest U.S. Coast Guard icebreaker, was just one of several ships that took part in that year's expedition. South of the Healy, the Canadian icebreaker Sir Wilfrid Laurier also provided a platform for studies of environmental changes occurring at the bottom of the northern Bering Sea. One of the members of that team was Michigan State's Knight Center for Environmental Journalism's Alicia Clark. Alicia remembers her Arctic experience.
I went up there as a student worker and I helped collect biological samples for them, and I also worked on a small project collecting phytoplankton in the Bering Strait. And it was truly amazing. Midway through, we took a small Zodiac boat out to the island of Diomede, Little Diomede, and it's about a mile away from the international date line, and it's inhabited by a small population of Inuit. And they were absolutely wonderful in welcoming us into their community, and a lot of the little kids took us around the island and showed us their school and their houses and their dogs. And so it's just really amazing to see the people of the Arctic and the wildlife and just experience science, just pure science in the Arctic. So it was a great experience.
As the climate changes, so does the Inuit way of life. This has been their native land for thousands of years. In recent times, they have seen and felt the changes taking place.
People have seen changes. I mean, you can just talk to the local community, too. I mean, I was just on Diomede Island, and they had the ice was such that their hunt was basically a failure. And that's a community that subsists on hunt.
These days, the mission of research vessels in bringing scientists into the Arctic isn't as hard as it once was. According to Dr. Grebmeyer, ocean ice is breaking up about 3 weeks earlier than it used to. Humankind's vision of a permanently frozen Arctic is beginning to melt away.
I think people in our lifetime, there have been meetings to talk about 2050 an ice-free Arctic. That's an extreme, but people are actually thinking that may happen.
So I was surprised about how it wasn't warm, but I was expecting it to be a lot colder.
That change is being reflected here, off the waters that were once covered by oceans of ice. Not only an indicator of climate change, the open-air waters actually speed the impact of the warming trend. This is how it works. Ice and snow have a high coefficient of reflectivity, meaning much of the sunlight that hits them bounces back into space. When the ice and snow melt, the darker ocean surface absorbs the energy of the sunlight instead of throwing it back, and that causes the water to warm even faster. And warmer water releases more carbon dioxide into the atmosphere.
You can go back hundreds of thousands of years, and there's more CO2 in the air now than there was then. And then, given the characteristics of carbon dioxide in terms of its heat trapping capacity, if there wasn't some consequence, and the consequence would be warming.
In the shallow areas off the northern Bering Sea, the seafloor is teeming with life. Sea worms, bivalves, and other tiny crustaceans call the muddy seafloor home. These tiny creatures are the base of the region's food web, and the animals at the top of that food chain, like the polar bear, owe their very existence to them. The research has shown, however, that the quantities and sizes of these creatures have been in decline. The primary suspect? Climate change.
I think it would be very surprising if given what we're doing in terms of a global atmospheric experiment in adding carbon dioxide and other greenhouse gases to the atmosphere, if that didn't have some consequences that would look like global warming.
The Arctic's ecosystem is incredibly intricate, interconnected, and delicate. Changes in water current due to large-scale wind and precipitation patterns not only adversely affect creatures living on the sea floor, but the many ecosystems for which they are a basic food source. Above the water's surface and just below the Arctic Circle, land-based ecosystems are also being disrupted by global warming, turning once solid ground into a soupy quagmire.
What we're seeing, though, is with warming climate, is that permafrost is starting to degrade, and this has really big consequences for our plants and animals in these ecosystems.
Dr. Merit Turetsky's work in the boreal regions has resulted in some disturbing findings.
And so what we start to see are these depressional sinkholes forming in some areas due to thermokarst, permafrost degradation, that form very soupy, even wet, more wet than they started out. And so we can see areas with roads or buildings that were stable one year with the onset of permafrost degradation. They're slumped down into the ground, roads collapse, buildings start to lean over because their solid ice cube is no longer solid. It's now a soupy mess.
The area is known as the boreal or northern forests. It encompasses 3.7 billion acres, or 11% of the Earth's land surface. Nearly a continuous band of evergreen trees, deciduous forest, and cold desert, it stretches through parts of Alaska, Canada, Russia, Scandinavia, China, Mongolia, and Japan. A sustained temperature shift of only a few degrees can affect nearly all the elements of a boreal forest. From the soils and waters to the flora and fauna, the consequences can be extreme.
Some of the permafrost areas in upper regions of Canada and Alaska and Russia are very rich in organic carbon and frozen most of the year. If they begin to thaw, it's very likely that they will break down relatively quickly and episodically release a lot of CO2 to the atmosphere.
It causes a complete transformation in our terrestrial ecosystems, so both wetland habitats as well as forest habitats. Areas that had been dominated by trees and dry-loving mosses and lichens that feed caribou, for example, are now semi-aquatic lakes and very, very wet wetlands.
As the water warms and its state of matter changes, frozen land becomes wetland, and wetland becomes dry land, ripe with fuel for burning.
The prevailing notion in the literature among scientists has been that these ecosystems are too wet to burn. What we know now is that because of climate change causing warmer, drier conditions throughout the boreal forest region, these wetland systems are no longer too wet to burn. So our wetlands of the north are no longer wet necessarily, and they are becoming more and more susceptible to fire.
These fires were intentionally set for research purposes by the Canadian Forest Service, not only to gain information regarding firefighting techniques, but also to measure the chemical composition of the smoke.
Now, fires in the north, so both in boreal and in Arctic regions, are large. They're big disturbance events, and they're very severe, so they can consume all of the vegetation within the ecosystems that come in their path. And some of the fine fuels within peatlands, like the shrubs and the tree needles, will burn. But when the peat itself, the soil, catches on fire, that can lead to smoldering.
That smoldering can last for years, continuing through the harsh, dark winter, all thanks to its enormous fuel supply. More carbon is stored in the boreal region than anywhere else on land. In Canada alone, the boreal trees, soils, waters, and peats lock away 186 billion metric tons of carbon, enough to balance Canada's entire greenhouse gas emissions for nearly 1,000 years.
Now, fire is an example of something that we're very concerned about in terms of generating a positive feedback loop. We're seeing ecosystems burn more frequently. That releases greenhouse gases to the atmosphere. Greenhouse gases as carbon dioxide, as methane, and as carbon monoxide, so all three types of carbon-based greenhouse gases, which causes more warming, and so that is the vicious loop that we're worried about.
But beyond these concerns, there looms even more disturbing issues. One of these issues deals with the release of mercury. In a naturally occurring state, mercury isn't considered to pose a significant threat. However, when fossil fuels such as coal are burned, mercury becomes an airborne byproduct. Released in the smoke, it's carried into the air and pushed along by prevailing winds. It eventually settles in the far north. But like a reoccurring nightmare, as the areas in the north begin to heat up, melt, and dry out, centuries of mercury emissions trapped deep in vast regions of permafrost are being re-released through smoke from wildfires.
We started to measure the amount of mercury that was stored in peat and in vegetation in different kinds of ecosystems, both in Canada and Alaska. And the first thing that our study indicated to us is that these systems, these ecosystems, have been storing a huge amount of mercury. If that mercury does get deposited to the surface of a peatland, it binds to the peat itself and then subsequently becomes buried within the peat profile. So the very nature of peat accumulation in these northern wetlands have not only been locking carbon away from the atmosphere and performing this very important ecosystem service, but they've also been storing our industrial mercury. And we estimated that the amount of mercury that can be released during a large wildfire season in places like Western Canada can exceed industrial emissions of mercury across all of North America. That is Canada, that is America, and Mexico combined.
In a flash, thousands of acres of dry boreal forest can be lost, up in smoke, like a toxic cloud laced with sulfur dioxide, carbon monoxide, and centuries' worth of accumulated mercury. In their wake, these blazes not only poison the air, but their smoke blankets the ice with ash and soot. And the darker the ice, the faster it melts.
If a surface is ice covered, it doesn't warm up very efficiently. But once the ice leaves, those surfaces have a greater ability to warm up and retain sunlight that they couldn't do when they're ice covered. And so there is a feedback mechanism whereby once we start melting the ice in the Arctic Ocean, it perpetuates. And there's very good indication to think that we've crossed that point very recently, if not this year. So we're very likely to see the rate of ice cover in the Arctic continue to decrease and markedly decrease. And it's a very strong question in my mind is how the ecosystem will respond to this.
But the problem today isn't only in some far-off place. Changes are starting to take place in our own backyard. This is Lake Superior. It is the largest freshwater lake in the world. Over 10,000 years ago, the first of many tribes of indigenous peoples called the lake shores home. Names like the Plano, the Algonquin, the Dakota, Fox, Menominee, and the Chippewa conjure up a picturesque journey through time and history. Today, much of what drew many of these native settlers to Superior's shore still exists. Fishing, hunting, and the splendor of the lake itself bring a sense of amazement and wonder. Amazement and wonder have also spread to the scientific community. Researchers are trying to understand the recent changes that have taken place at the Great Lakes. The diagnoses are worrisome. Earth's fever is spreading faster than anticipated.
There's been some very dramatic changes in the surface waters of Lake Superior. From what I understand, there's been a 3 or 4 degree temperature increase in the past 30 years. And so this is really substantial. This is a system that's responding very quickly to global warming and changing very rapidly.
Winter ice cover on Lake Superior acts like a giant mirror, reflecting the sun's rays and helping reduce the effect of the dry, thirsty winter wind, drawing millions of gallons of water from the lake's surface. But as the climate warms, the ice cover is reduced, and lake levels reach record lows.
The other response to a reduction in ice cover in Lake Superior is there is likely to be increased rates of evaporation off of the lake surface. And we are currently seeing a sharp decline in lake levels throughout the Great Lakes, and particularly in Lake Superior, and they're currently at historically low levels.
The study of natural phenomena such as tree rings, ice cores, and sea sediments have given scientists a wide perspective and a clear look into past weather patterns. That information supports the conclusion that the planet's warming in the last 50 years is historically unusual when compared to the last 1,300 years.
Lake Superior is a vast lake. It's not likely to drop to the point of depletion anytime in our lifetime, but there are other systems in the Great Lakes which will be very markedly affected. For example, Lake St. Clair. I've seen some reports indicating that we may reduce the area of that lake by 40% in the next 100 years or so.
Shrinking lakes, rising oceans, melting ice. Changes to the Earth's climate mean changes not only to plants, animals, and weather, but also to jobs, business, and farming. Dr. David Skoll is a professor of global change science at Michigan State University. He and his colleagues use cutting-edge technology to monitor global ecosystems and provide support for sustainable agriculture and natural resource management.
We need tools that can measure what's going on at the global scale. And one of the great tools is the use of Earth-observing satellites.
These satellite images compress years into seconds, allowing researchers to witness the forests melting away.
Deforestation is a significant issue, and let me put it this way. Let me put it in terms of the Kyoto Protocol. The Kyoto Protocol was an international agreement that was ratified by all countries except the United States, and under the terms of that protocol, countries agree to reduce their emissions of greenhouse gases, by about 7% below the 1990 levels by the year 2012, because none of the gains through the Kyoto Protocol will make any difference if we don't arrest deforestation.
But offering a good alternative to rural farmers is not easy.
Put yourself in the shoes of a rural farmer who might be growing a subsistence crop, and you come along and say, don't do that, plant trees. Well, that's not a bad option, except that you have to wait until those trees produce the benefits. So it's not really that great of an option for many, many farmers, particularly those rural people living on $1 a day or less. And there are billions of people that are in extreme poverty.
Designing a program that makes planting trees profitable for a rural farmer is a challenge. But eventually, reforestation programs could pay out to farmers with fields of saplings. Still too young to produce fruit, timber, or even shade, the saplings would still be an environmental commodity when sold as carbon credits to businesses, oftentimes a world away. Proposals like these represent some of the new thinking that's beginning to take root.
And there's something that's looming out there for all boardrooms, and most boardrooms get it, and some get it more than others. And that is carbon risk. Stockholders are asking for action. So this is creating an environment in which if you do nothing, your company is set up with huge carbon risk.
The planet is not on a path of self-destruction. Nature is pro-life. Given even the smallest opportunity, life thrives in even the harshest environment. But the changes nature has been forced to make may mean drastic changes in all of our lives. The Arctic has sounded the alarm. The question now is, has our response come too late? It's what scientists are calling the tipping point of change.
You know, has the ecosystem reached a point where it's changing and irreversibly changing? In other words, can't go back to the way it was before. And there is some strong belief or strong indication that the Arctic is changing in this manner. So we've wondered, because the rate of increase is increasing, whether we haven't crossed that tipping point.
For animals like the Arctic's polar bear, their dependency on disappearing sea ice has environmental groups at odds with federal agencies that some say are dragging their feet in declaring the bear as endangered. Not many have the opportunity to observe these creatures in the wild, and for the scientists and researchers on the Healy, it's a sight to remember. The scientific experiments had taken nearly an entire workday to set up, but the curious bear, perhaps sensing the possibility of a meal, just couldn't resist. As the ice that these animals call home simply melts away from beneath their feet, for many of us, our memories of them living in a seemingly boundless environment may one day be replaced by this: a lifetime spent surrounded by concrete walls and artificial pools. The sight of these creatures living in a zoo is considered by many not as a sign of success, but rather of failure. Failure not only to them, but to ourselves.
It's not easy being green. Kermit the Frog once sang those words, and they ring truer today more than ever. Michigan State University has launched an environmental program that has become a model for institutions, communities, and individuals. Teams of researchers, citizens, and scientists are searching for big and small remedies for environmental headaches. Everything's on the table, from paper use to power plant fuels. Michigan State scientist David Skoll says that global warming is not a political issue, but a problem that requires a lot of smart people trying to come together to find a solution. While it may be hard being green today, if we don't start thinking smarter, it'll be a lot harder tomorrow. Until next time, I'm Jamal Spencer for Environment.
This has been a presentation of Michigan State University's Knight Center for Environmental Journalism.